All right, so chapter 8 is on graphing. What's called, or graphing quadratics. And they put it in function notation. Remember, we could also just write y equals ax squared. So if either one of those means the same thing. And so what a graph of anything with x squared looks like is a u. It could be upside down, and we'll get to that. But this is called a parabola. So if you see that word, that's what we're talking about. And there's some parts that are very important to this. And the first is we have this kind of imaginary line that goes right down the middle. And this is called the axis of symmetry. It's very helpful because the graph, whatever it looks like on the left, it looks exactly the mirror image on the right, and vice versa. So if you were to fold your piece of paper over, where the fold is right on the axis of symmetry, the graph should match up right on top of each other. And that helps us a lot, and I'll get into that when we do some examples. Okay, then we also have this point where at the very bottom, or it could be upside down, and it's on the very top. And that point is called the vertex. Okay, so that's also an important point because that when you're graphing it, that changes the direction. As I'm drawing the graph going down, then it turns to go back up, or vice versa. Okay, so those are the major components to a parabola. Okay, so we're going to graph these in stages. So the first section, the graphs are going to be a little bit easy to do. The second one, it'll get a little harder, but not a lot. And the third one will be like the full complement of how we do it. All right, so let's look at what's called the parent graph. So it's just y equals x squared. Okay, and I want to show you this because there is kind of a pattern to how we're going to do things, and I'll get into that as we keep going through the different concepts. But the week before spring break, we kind of started with just plugging in numbers and seeing what we get, because we're going to have to do that kind of quite a bit. So 0 squared is just 0. If I put in 1 squared is just 1. If I put in 2 squared is 4. If I put in -1, -1 times -1 is +1. And if I put in -2, -2 and -2 is 4. So I'll go into a little more detail once we kind of get going on some other problems, but what I wanted to kind of illustrate on this problem is kind of our baseline pattern, if you will. Okay, so first of all, when we graph these, it's not a V. Okay, if I made a straight line from this point to this point, it goes way over like that. So it's not a V. We're not making straight lines. So the best that you can, we're going to need to make it a rounded thing. All right, so this is kind of our parent, what's called a parent graph, like our beginning like graph. And so what I want to point out, because this will be useful moving forward, is we have the vertex. This one happens to be 0, 0, right at the center of the graph. And honestly, all of our graphs today are going to be at 0, 0. And as we get going later, I'll explain why that works. But the pattern is over 1, up 1, over 2, up 4. 1 squared is 1, 2 squared is 4. Okay, that's a baseline pattern that's going to come up, and I'll show you kind of how we can use that sometimes. Okay, all right, so there is a process. It's got to look like that. Okay, there's points over there on the left side. So if you, just like over here, if you look at this point, it's 1 to the right, and then I have another one that's 1 to the left. Okay, like right there. Just like on this one, this higher one, 2 to the right, 2 to the left, up there. Here's graph of x squared. I'm going to copy that one over onto this. Remember our pattern, over 1, up 1, over 2, up 4, that we're going to use to graph. And the first process is find the axis of symmetry. Step 2 is plug in the axis of symmetry to find the vertex. And then plug in 2 additional numbers for x to create points. Okay, so that's for what's called standard form, which is what we're doing. That is the process. When we're going to do stuff in a couple weeks, or maybe even next week, maybe the end of next week, where we do what's called vertex form, or there's intercept form. But for standard form, which is what we're starting, this is kind of what we need to do. So remember, it could be f of x, it could be y, but let's graph like 2x squared. Okay, so find the axis of symmetry. How do I do that? There's a little formula called x equals negative b over 2a. And so remember that our quadratic, we talked about this last chapter, but ax squared plus bx plus c. So the a, b, and c are like those, like we did last chapter. Well, today's lesson is only on graphing ax squared. There's no bx, there's no c. So if there's no b, the axis of symmetry, like that's going to be a 0. And then the a could be different. I have an a, which is a 2. Excuse me. So if I were to do the axis of symmetry, it's going to be 0 over 2 times 2, or just 0. 0 over 4 is 0. Okay, so listen carefully. If there's no b, like there's no 4x or negative 5x or anything like after this, 100% of the time, the axis of symmetry is x equal 0. You can memorize that. It will 100%. There's never an exception. If there's not a something x, like the bx way over here on the right, if there's not something like that, the axis of symmetry is always x equals 0. You do need to memorize this x equal negative b over 2a, because when there is the next part, then we got to do that. Okay, but for today, axis of symmetry is x equals 0, 100% of the time. All right, so step 2 says plug in the axis of symmetry to find the vertex. So plug it into the problem. 2, 0 squared. 0 squared is 0, and 2 times 0 is 0. So remember that I'm finding the vertex, which is a point. So I'm combining these two things together, and the vertex is 0, 0. Okay? So listen carefully again. If there's nothing else but the ax squared, like this beginning part, I don't care what number you put where the 2 is. Not the squared part, but the 2 in the front. Positive, negative, fraction, whole number. It doesn't matter what it is. If you plug in 0, you're going to get 0 100% of the time. Because anything times 0 is anything, is 0, sorry. Okay, so for today, because there's not going to be anything else after it, the axis of symmetry is 0. The vertex is 0, 0. All the problems. Okay, so over here, I'm going to start to graph, and so let me put that down lower. Okay, so 0, 0 is where we're going to start. Okay, plug in 2 additional numbers for x to create the points. So I pick the next 2 numbers either to the right or to the left. It does not matter which. I tend to go to the right because those numbers are positive, and typically that's easier. But if you had like your vertex was over to the right already, and you could pick positive numbers that are to the left, then that's fine. But today, pretty much we're going to pick 1 and 2. So if I plug in 1, 1 squared is 1. Okay, so I just created a point like we did on our worksheets last week. I plugged in 1 and I got 2. Okay, and then I'm going to plug in 2 because that's the next number over. Okay, so 2 squared is 4, and 4 times 2 is 8. So again, I plugged in 2 and I got 8. Okay, now the graphs of U. Remember what I said, the axis of symmetry is actually, it's it's an imaginary line, but it's right down through the middle. And symmetry means it's the same as on the right as it is on the left. So this point, 1, 2, is one space to the right of that blue dotted line. I know it's kind of like hard to see, but it's 1 to the right. So I'm going to have another point that's 1 to the left. And then this one up here is 2 to the right, so I'm going to go 2 to the left. Okay, and now I have 5 points, which is really what I should have to graph these. Okay, so there's the graph of y equals 2x squared. So if I do over 1 up 1, I get a point here. Over 2 up 4, I get a point here. And then I can flip them over. And so if you notice, that parent graph is a little bit wider than when I put a 2. Okay, the other thing, if you notice, when you go over 1 and over 2, the points are getting farther apart. Right, so remember we said over 1, up 1? This one's over 1, up 2, over 2, up 4. So this one, over 1, up 2, over 1, up 8. So remember the pattern on the other one was over 1, up 1 on the, you know what, let me do that in red. So the black one, the over 1, up 2, over 2, up 4, or excuse me, up 8. The red one is over 1, up 1, over 2, up 4. Okay, so we went from 1 to 2 and 4 to 8. It's times 2. Which is that number in the front? Okay, so it's the same graph, it's just times 2, which means it's going to go up faster because it's going up twice as fast. Okay, so that's a component that we're going to have to deal with. Okay, so when we look at the problems graph, it made the points go up faster. Instead of over 1, up 1, it went over 1, up 2, or over 2, up 8 instead of 4. It went up fast. So this is how 4 or 5 of your problems are going to look. So we just graphed it, but it's going to say graph that, and then it's going to say compare to y equal x squared, or it could say f of x equals x squared. Remember, they're the same. So you're really looking for what's different. Well, the 2 is what's different. And what did the 2 do to how much faster? Twice as fast. So we've used this term a long time ago, but the 2 in the front, we call that a vertical stretch by 2. The points are stretching out twice as fast. Okay? So let's look at another one. I'm going to do 2 things here. -1/2. Okay? So if you remember, I said when there's no b part, the axis of symmetry is x equals 0. So you don't have to plug in because you can do 0 divided by something, and that answer is always 0. And then I also said that the vertex, if there's nothing else after the x squared, which all the problems today, there will be nothing after it, 0 squared is 0, 0 times -1/2 is 0. For today, the vertex is 0, 0. Okay, so I don't mind you just kind of writing that down. All right. So now we need to plug in. So we have 0, 0 for our vertex. And the axis of symmetry, again, is right along. I'm not putting it a little bit to the left of the black line, otherwise you can't see it. But it's right in the center. So I said pick 2 numbers to the right or to the left, but I don't want to do negative numbers if I don't have to. So if I put in 1, I get negative 1/2. 1 squared is 1, and negative 1/2 times 1 is negative 1/2. And yeah, it's a fraction, and I'll talk about that in a second, but I want to illustrate something. So when I plugged in 1, I got negative 1/2. So 1 and down 1/2. Okay, so you can just estimate it. That's close to the middle. And then I'm going to plug in 2. Negative 1/2, and I plug in 2. 2 squared is 4, and half of 4 is 2, but negative 2, because it's a negative and a positive. So I plugged in 2, and I got negative 2. Okay. All right. Then I plugged in the 2 points. I remember I get to flip these over to the other side. So this is, even though it's a half, it's still 1 to the right, so I do the half, but 1 to the left. And down, this one's 2 to the right, so I do 2 to the left. And so we have a graph that goes upside down. Okay. All right, so the negative in the front is what made it go upside down. Okay, if you see a negative in the front, it's going to go upside down like that every time. There's never an exception. Okay, so if this was just y equals negative x squared, remember our pattern, over 1, up 1. So it'll be over 1, down 1 because of the negative. So it would end up like here, over 1, down 1. And then if I did over 2, up 4, it's going to go down 4. And then it will flip over. So the x squared graph now is like the black one, or the 1/2, it's getting wider. Okay, and if you notice, like here's our points again, that kind of over 1 and over 2. What's happening on this one? Well, instead of going down 1, it only went 1/2. Instead of going down 4, it only went half of that, down 2. It's going half as many spaces as it's supposed to. So instead of over 1, up 1, and over 2, up 4, again, we're going down because of the negative. But instead of 1 and 4, we went 1/2 and 2 down, or if there was no negative, it would be up. So the distance is getting smaller. Okay, so when the distance is getting smaller, we're going to graph this. And when we do the compare, we have what's called a vertical shrink, because the distance is smaller by 1/2. And because it's upside down, we have a reflection over x-axis. Okay, so on all your problems today, you're going to have a vertical stretch or a vertical shrink, one or the other. And then it's just the number that's in front. If you have a negative, the graph should go down, and then you'll have a reflection over the x-axis. Okay? All right, so your first couple problems are going to say, identify the characteristics of the function and its graph. So I want you to list the axis of symmetry and the vertex. That's really all I want you to kind of put. Remember, the axis of symmetry is going to be x equal So draw an imaginary line through the middle of the graph, and then wherever it hits the x-axis, that's the axis of symmetry. So if it hits the axis at 1, the axis of symmetry is x equal -1. If it hits it at 2, x equals 1. If it hits it at 2, x equals 2. If it hits it at 4, x equals 4. If it hits it at -1, x equals -1. Okay, just extend it through. Okay, then you're going to have 4 to graph. And so one of them is a fraction. It says 1/4. Now, you can pick any numbers you want to plug in. So it'll be easier if you pick, when you have 1/4, if you pick 2 and 4. It'll make your graph a little bit wider, but it will also make the graph not have a fraction. So if you pick 2, 2 squared is 4, and then the 4 on the bottom will divide. And if you pick 4, 4 to the second power is 16, but then you're going to divide by 4. So it makes it a little bit easier. And then you're also going to have a problem that it starts out like this, -0.2 x squared. Make that -1/5 x squared. So for sure on that one, this is kind of a different one. Pick 5 and 10 to plug in, because it'll divide by 5 and it'll make it a little bit easier. Now the graphs are going to be really wide because you got to do 10, but it'll make it 100% easier and you won't have to do fractions. Okay, so if you have a fraction, pick the denominator to plug in. All right, so if you don't 100% get this today, we're going to add one very small piece to it tomorrow, but everything else will be the same. Okay, so tomorrow will be another chance to kind of make heads or tails out of this thing. Okay, all right, have a great day. Welcome back from spring break. We'll see you tomorrow.